All right, guys, last video for the week. What we're going to talk about in this one is writing quadratic equations based on the roots or the zeros. I think that you are going to find this to be the easiest of the three topics that we've talked about this week. The sheet that I'm going to use when I go through and explain this and do some notes with you is going to be the same sheet that you are given for homework. So I'm going to do a couple of problems off of this, and whichever ones I skip over, those are the ones that I would like you to go back and finish up for homework. Okay? All right, so going through this, first thing, when you are given your quadratic, the first thing that you want to do is you have to identify the roots. So right here and right here, remember the roots are where the graph crosses the x-axis. So in this case, our roots are -4 and 2, okay? So now that you know what the roots are, you have to think about, well, what would the factors be before we went through and solved for those roots, okay? What would have those original factors been before we went through and got the x equals -4 and the x equals 2? And what those will end up being is the opposites of whatever your root values were. So if we think about if you had y equals x plus 4 and then x minus 2, these are the two factors that we would have had originally. Then you would go through and set them equal to 0 and you get your roots for your answers. So this is like we're going backwards, okay? So first I find my roots, then I think about, okay, if those are my roots, what would have the factors had been, okay? Now that we have this written in factored form, now I could FOIL x squared -2x plus 4x minus 8 and combine the like terms. So the original quadratic equation was y equals x squared plus 2x minus 8. Okay? So then you would do the same thing for letter B, find your roots and work backwards. Okay? All right, if we look at letter C. So when I look at letter C, I notice this time I only have one root, 5. Okay, so it's a quadratic. So I know that I still have to have, like two factors. So I'm going to think y equals x minus 5 x minus 5. That's one way you could think of it. Or x minus 5 squared would be the same thing. Okay? And then I could go through and FOIL this out or multiply this out, and I would get my final answer or my final equation, y equals x squared minus 10x plus 25. Okay? Letter D, I think you could do on your own. Letter E, you can do on your own. For which function defined by a polynomial are the zeros of the polynomial -4, -6? So this one you're just going through and you are solving. And notice some of the answers go on to the next page. I don't know why when I convert it into Cami, things don't line up anymore. All right, B you can do on your own. Okay, so right here, letter C. Letter C, it's saying the graphs below represent functions defined by polynomials. For which function are the factors of the polynomial x minus 2 and x plus 3? So if these are your factors, we're going to then go through and find the zeros. So if one of the factors is x minus 2, that means that your x value has to be positive 2. Well, graph number 4 goes through positive 2. Graph number 2, it does not cross at positive 2. Graph number 1 does not cross at positive 2. So now let's solve this one. X plus 3 equals 0. That means x is going to equal negative 3. Graph number 4 does not go through at negative 3, but graph number 3, it crosses at x equals 2, and it crosses at x equals negative 3. So that would be our answer. Okay, third degree polynomial. Third degree polynomial is where you would have like x to the third power. Okay, third degree polynomial is going to be two curves. Okay, so when we're thinking about a third degree polynomial, you could have 3 roots. You could have 3 zeros. It's going to cross that x-axis at 3 points. Okay, so if we think about, let's look at letter A here. There's 2 different graphs this possibly could look like. It's saying that we have our 3 factors. Y equals x, x plus 7, x minus 3. Okay, so if I were to go through and solve these, I know that x could possibly equal 0. So it's going to cross at x equals 0. It could also, it has a 0 or a root of x equals negative 7. And the last root is going to be x equals positive 3 right here. Okay, I don't know which way the curves are going for this one. I just know what the roots are. So I can draw in my curves one of 2 ways. All right, if these are roots, I know halfway between I would have a vertex. So I could say this curve could look like this. And I could say this could come down like this, and it could go back up like this. It has 3 roots, and it's crossing that x-axis at those 3 different spots. And we could do the same thing over here, except this time, and I'm going to leave this one for you to do on your own. You know, you have your 3 roots. You could have a curve that comes down like this. Okay? But I'm going to leave that for you to try on your own. Okay, so those are going to be the only ones that I'm going to go over. Letter B, it says sketch 2 possible graphs that have the factors x minus 4 and x squared plus 9x plus 14. So my only little hint for you on letter B is that you do need to factor this out to see what the other roots are. Okay? And letter C, you're writing the equation of this. So this is just like when you're writing the equation of a quadratic. You're going to find the roots. You're then going to write the factors that you would have had to get those roots, and then you can multiply it out. Okay, I hope this helps. Again, email me if you have any questions, and I hope you have a wonderful weekend if I don't hear from you prior to when you hand this in. Bye, guys.